Hello guys, welcome to this first video that is related to the topics that we will be covering uh, during this course or doing together. In this small cast I will introduce the two software tools we will be using during the semester and maybe give you a hint on the reports and how you should be writing them, knowing that you will be submitting them individually at the beginning of every lab. Due to iOS website restrictions regarding file size, I might have to split this video into 2 or 3 parts. We will see. Anyways, the first part we will discuss MATLAB as a software tool. So MATLAB is a matrix-based computational tool, and when you open it, it has some kind of a default layout with different windows. We can see here some of them, and like every Windows-based software, you can dock, undock the windows to have the layout of your preference. You can maximize, minimize, and change the place of the windows. Everybody has his own preference. Now, to get back my layout, I have to suffer a little bit, but that's it. Alright, the command window, this one, is where the action takes place for a new user of MATLAB. Things will be written here, some commands, some variables will be defined, and so on and so forth. The workspace, on the other hand, here is a place where all the active variables are shown. So if I try to ask MATLAB to give me the value of A, it will produce an error, undefined function or variable A, because it doesn't know what A is. But if we define A to be 5 or something like that, then the workspace keeps the variable A, its value, and there are many other properties that can be shown here regarding the different variables that you will be working with. Now, this is not a MATLAB course, it is just a small cast to break the ice with MATLAB. So many of the commands I will be fast in implementing them because of the nature of this small cast. So clear clears the variables, clear all or clear, and CLC cleans the screen. All right. There is the current folder window. Again, it comes with a default layout but can be changed, redocked. All the files that you will be dealing with or working with your programs, your functions in MATLAB are kept here in the current folder. MATLAB can work with variety of files, images, sound files, datasheet, different files, and as well as MATLAB's own files, the script files, which is .m, then the data files .mat, and the figure files of MATLAB. Okay, the last window is the command history. From its name, you can save the commands that you use here in the command history for as long as you wish. So you can decide through the properties of this window, and you can clear the command history, and you can keep the commands for a certain time, then clear it. It's up to you. So all the commands that you have used, they can be kept here, and that's a good thing because you can always go back and see some of the commands. I don't know really when did. So unknown date. Let's see. For instance, this one is from New Year's Eve 2014 to 2015. That's like 10 months ago. Interesting. Alright, so that's the command history. Okay, let's now do some things. First, I think that I can a little bit change the font to make it bigger so you guys can see it if you cannot see it. So here is, I don't know, 80 maybe. Okay, I think it's bigger now. You can use MATLAB as a calculator. 5 plus 6 is 11, and you can use it as a calculator for complex numbers as well. 6i plus 4 minus 3i, that is 9 plus 3i, that is a complex number. And you can do all the operation as any regular calculator with regular numbers, or I mean real numbers or complex numbers. This is the easiest thing. You can assign variables. A equal 5 plus 8i, b is 3 plus 5i, and then you can a plus b, add them, a minus b, a times b, and so on and so forth. Okay, I think that my screen went down a little bit, so okay, let me fix this so that you can guys see what's going on. Okay, here it is, a times b, and so on. Now there are many functions in MATLAB, built-in functions, and you can make your own functions like sines, cosines, tangent, exponentials, so many built-in functions, and you can make, as I said, your own functions. One of the strongest sides of MATLAB is actually its visual capabilities and graphical capabilities. So plotting functions or any data sets in MATLAB is actually fun and very, very easy. To see that as an example, let's say that I have a variable time and it's defined from 0 with a resolution 0.1 to 10. Okay, and there is a function which is as a function of time, let's say 1.3 times sine 2 times time. Now this is an arbitrary function, I'm just making it now, plus, I don't know, 3.1 times cosine, again maybe 1.7 times time. Okay, so this is the frequency, and of course depends on the way you define your frequencies, radians and hertz and so on and so forth. Now we have this independent variable, which is time, and dependent variable or the function of it, which is f. We can simply plot time versus f, and we get this lovely plot of our function. Now if we play a little bit with this guy, so I will do the following so that you can see the plot when it changes. If I make this 1.1 and maybe this one 0. I don't know, 9. So now I'm changing the variable f or the function f, and again plot time versus f. We get a new function now, or a new plot, which is fun. Okay, now to be a little bit more practical and to have a simulation of a real situation that you might encounter in the lab, so we will see this group of data, assuming you were given an assignment in the lab to see what happens with the current across a capacitor, across a resistor, through a resistor, a current through a resistor when you apply certain voltages. So here are the voltages, and this is the current according to the formula. You will learn that formula, which is called Ohm's law, at the proper time. Then you do measurements. You apply same voltages which are given in the ideal case, but the measurements are a little bit different. Now the difference in measurements is typical thing in labs because of tolerance issues and instrument issues and human error issues and so many other issues. And you are asked to compare your measurement to the ideal case. So what we can do is actually define a variable here, I don't know, independent variable int v equal, and we say it is 1, 2, 3, 5, 9, and 12. Those are here given in the problem. Then ideal case is 3, 6, 9, 15, 27, and 36. Practical case, pract. Now naming the variables, it's something depends on the person's, so it's up to you what you will be calling your variables and what kind of system of naming variables you will be using. 15.5, 27.6, and 36.5. Okay, now I'm using the semicolon to suppress the output. If I don't use the semicolon, if I keep it, the output will be shown here. I mean the variable itself will be shown here. But it is annoying to see, especially if the variables are big, like hundreds or thousands of values, so it will become a nasty window. That's why MATLAB provides the semicolon to suppress the outputs. Okay, now we have our independent variable, practical values, and ideal values, and we just want to plot them against each other to see, do they make sense or not? I mean, do our experiment make sense or not? So we used the voltages or whatever the values is, and ideal. So this is going to be one plot. At the same plot, I want to do again, I want to plot the independent variable against the is it? Yeah, practical variable, and I want to make it, the last one, dotted for the sake of comparison. It is not dotted, it is with a star. I hope this will work. If we run this guy and we get this this answer or this plot, and as you can see, there is a small drift between the practical and the ideal, which is of course normal. Now the question is, do we accept this values or not? It's up to the experiment, up to you to interpolate these or to decide whether the experiment is successful or not according to the values. We can visualize this in a different way. Maybe we can just remove this and keep it simple. So you have two lines, as you see. You can zoom in and you see how much is the difference, is it acceptable or not, and so on and so forth. Okay, so this is just the tip of the iceberg. As I told you, the idea of this video cast just to break the ice with MATLAB. You will be using during the whole semester, so please try to master at least the basic functions and plotting, defining variables, manipulating variables. I will be providing you with some literature and some web links where you can find good tutorials, and of course I'm available if you need any help. Thank you for your time.